In this video, we'll look at delete operation. There are two cases for deletion, just similar to linear linked list. Two cases are deleting head node, that is this node. So what is special in this one? If this node is deleted, then some other node you have to make it as head node. You have to move head. So whichever one you can select because it is circular. So we will be selecting just next node as a head node. Now second one is deleting a node from given position. So any other node like third node or fourth node, fifth node, deleting a node from any given position. So this procedure is same as deleting from linear linked list. So first let us look at this procedure. Let us look at these steps quickly because we already know about this one. Then next we will look at deleting head node. So let us see deleting node from a given position. Let us delete a node from fourth index, that is this node I want to delete. So what is the procedure? If you want to delete this node, then you should manipulate this node and make this third node point on fifth node. Then you can delete this node. So for that, I need a pointer on this fourth node also and third node also. So you remember we will have one pointer, that is a tail pointer. So we'll take two pointers. One pointer will be moving and the second pointer will be following. Or else we can bring a pointer till third node and take one more pointer on next node. Or we can bring two pointers from the beginning. So two options are there. So now I will be bringing just one pointer from here till third node. Then I will take one more pointer here. So I will not be moving two pointers. I will be just moving one pointer. So let us see. Let us take a pointer P on head node. I have to delete fourth node. So I should bring it on 3. So how many steps it should move? 1, 2. So only 2 steps. Fourth node means just 2 steps. It means fifth node means 3 steps. So 2 steps less. So I need a pointer P. So I will directly write on the code P assign head. P starts from head. So with this, this for loop will move P for position -2 times. So P will be pointing on a node before the node which we want to delete. So fourth node means third node. Now I need a pointer on fourth node also. So take a pointer Q here. So Q is P's next. So Q is P's next. So Q will be pointing on the next node. Now what changes I have to make? P's next should point on Q's next. So P's next should point on Q's next. So P's next is pointing on Q's next. So this is over. Now I can easily delete this node. It's not a part of linked list. So I can take out the value and delete it. So take out the data in variable X and delete the node. So this procedure is same as deleting from linear linked list. Now let us see deleting head node. If I am deleting head node, this node I can make it as head node, but the last node should point on this new head node. So this is the modification I have to do. So if I am deleting first node. So for doing this, I should take a pointer P upon head node and move it until it reaches last node as per this head node. Then I should make that last node point on next node of head. That is, this link will change. It should point here. Then delete head and move head to this node. So head will be removed and this node is deleted. These are the steps. So for this, let me quickly write on the procedure for this one. So I will write on the pieces of code that perform these operations. I need P upon head. P will move until it reaches last node. So P is moved until last node. You already know the condition is P's next is not equal to head. Then P's next should point on head's next. So this is pointing here. This is pointing here. Then I should take out the data and delete this head. Data is taken in X. Delete head. This node is deleted. Then I should make head point on this node. What is this node? P's next. So make head point on P's next. So I have the code for deleting head node. I have the code for deleting any other node. Now analysis. The time taken for deleting head node is n because I have to take P till the last node. And the time taken here is minimum constant, maximum is n. So for which node it is minimum? Second node. If you are deleting second node, time is constant. Otherwise it is n. So I will write on a complete function for deletion and I will show you. So here I have a complete delete function. Let me read it out. If position is 1, that means I want to delete first node. Then we should have a pointer p moving up till the last node. So this is the code for moving up to last node. Then here I have taken the data from head node. In these statements, I am taking care here that if p is equals to head, means this is the only node. There are no more nodes, just there is single node in a linked list. Then if you make p point up to last, then p will remain there only. If there is a single node. Then if single node is deleted, then I should make head as null. So that I am taking care of here. So if there is a single node, then I should handle it specially. Otherwise, make p's next, that is point on heads next. Last node should point on this node, then delete this node and move head to this node. These statements are there already. We have seen these statements that are in single line I have written. Then this is the code for deleting a node from any other given position apart from index 1 or position 1. Now here again, I did not check the condition whether the position given is valid or not. And if I am not checking, what happens? You have to analyze this one. Figure out, take some position that is beyond this size 5 and take a linked list 5 and take the size as 6 or 10 or something. Then check what happens. While writing the program, I will write down that condition.